Welcome back to CryptoZombies. Today we're going to be exploring level 2 of the advanced Solidity path. If you're new to this series, I recommend checking out the original Solidity path if you don't know much about Solidity and programming on the Ethereum blockchain. Our main intention is to explore the intersection of Web3 blockchain technology and our foundation of voice technology to see how that intersection looks in the Web3 era. Let's get started. Deploying DApps with Truffle. Remember that we promised to teach you how to deploy a smart contract? It's been a while, but the time has come. In this lesson, we'll be teaching you how to deploy to Ethereum using Truffle. And that's not all. You're going to learn how to deploy your smart contracts to Loom as well. Why deploy to Loom? After all, Ethereum is the most secure network. Yes, we totally agree with that. But on Ethereum, each transaction costs gas, so your users will have to pay fees for each and every transaction. Also, they will have to wait at least 10 seconds for each transaction to be confirmed. In a nutshell, on Ethereum, all transactions benefit from the same security guarantees. So something like a user-facing dApp or a game, this level of security isn't always a requirement. In fact, it just harms the user experience. On Loom, users will have access to much speedier and gas-free transactions. This makes Loom a much better fit for something like a game or a user-facing dApp. Enough talking, let's get started. Starting off with Chapter 1, we've got 11 chapters today. Let's start with the introduction. If you're new to CryptoZombies, it's highly recommended that you go over the first 6 lessons before starting this one. Please take the time to get familiar with writing a smart contract, otherwise it will be very hard to follow this lesson. The missing piece. So you've worked your way through the previous lessons. Awesome. This means you've almost mastered the art of building dApps, but an important piece in the puzzle is still missing. That's right, you still have to learn how to deploy a smart contract. Now, if you have background in front-end development, you're probably well accustomed to the multitude of tools like Webpack, Gulp, or Browsify that makes the developer's life simpler. But what tools do Solidity's developers use? Truffle is the most popular blockchain development framework for a good reason. It's packed with lots of useful features. Easy smart contract compilation, automated ABI or application binary interface generation, integrated smart contract testing. There's even support for Mocha and Chai. Support for multiple networks. Code can be deployed to Wrinkby, Ethereum, and even Loom. We'll walk you through this later. Provided that NPM and Node have been installed on your computer, we'll want you to install Truffle and make it globally available. Put it to the test. We'll start with the basics. Fire up a new terminal window, create a directory called CryptoZombies, cd into it. Now let's install Truffle and make it globally available. Here's how you use npm to install a package and make it globally available. I don't know if we still have to cd into that folder. Let's just install it. Okay, then I think we want to make the directory of CryptoZombies. Create a directory called CryptoZombies and cd into it. Cd Oh. Not Truggle. We want npm install -g truffle. Okay, I'm typing it in the wrong order. npm install truffle -g. Okay, we got it. And if you haven't already done it on your local terminal, all you have to do is the same command, npm install truffle -g. And if you don't already have it installed, it will install it. I already had it installed, so it's just gonna check for updates and update my existing Truffle package. But yeah, that's it for level 1. We'll check the answer. We got it. I'm just gonna let that run. We're gonna move on. Next chapter. It's not liking the chapter skip. We're gonna have to do it manually again. Chapter 2, CryptoZombies. Getting started with Truffle. Now that we've installed Truffle, it's time to initialize our new project by running truffle init. All it's doing is creating a set of folders and config files with the following structure. We've got our contracts, our migrations, our test folder. Then we have a Truffle config file and our Truffle file. Contracts, migrations, test, it gets pretty complicated. Don't worry, learning how to use Truffle won't eat your brains. This chapter will walk you through Truffle's default project structure, and once you know how to use Truffle, deploying smart contracts will be a breeze. Truffle's default directory structure. So running the truffle init command inside of the CryptoZombies directory should create several directories and some JavaScript Solidity files. Let's have a closer look. We've got the contracts folder. This is a place where Truffle expects to find all our smart contracts. To keep the code organized, we can even create nested folders such as contracts/tokens. Pretty neat. Note, Truffle init should automatically create a contract called migrations.sol and the corresponding migration file. We'll explain them in a bit. Migrations. A migration is a JavaScript file that tells Truffle how to deploy a smart contract. 3. Test. Here's where we are expected to put the unit tests that will be Solidity or JavaScript files. Remember, once a contract is deployed, it can't be changed, making it essential that we test our smart contracts before we deploy them. Truffle Js and Truffle Config.js. Config file is used to store the network settings for deployment. Truffle needs 2 config files because on Windows, having both Truffle Js and Truffle.exe in the same folder might generate conflicts. Long story short, if you're running Windows, it's advised to delete Truffle Js and use Truffle Config.js as the default config file. Check out Truffle's official documentation to further your understanding. But why should I use this directory structure? I'm not used to it and it looks complicated. Well, there's a few good reasons. 1, Truffle's not going to work as expected if you change the name of these folders. 2, by adhering to this convention, your projects will be easily understood by other developers. To put it short, using a standard folder structure and core conventions makes it easier if you expand or change your team in the future. Then they've got a hardware wallet provider. In this lesson, we'll be using Infura to deploy our code to Ethereum, and this way we can run the application without needing to set up our own Ethereum node or wallet. However, to keep things secure, Infura does not manage the private keys, which means it can't sign transactions on our behalf. Since deploying a smart contract requires Truffle to sign transactions, we're going to need a tool called Truffle Hardware Wallet Provider. Its only purpose is to handle the transaction signing. Note, maybe you're asking why we chose not to install Truffle Hardware Wallet Provider in the previous chapter using something like npm install. Well, the truffle init command expects to find an empty directory. If there's any file there, it will error out. Thus, we need to do everything in the correct order and install Truffle Hardware Wallet Provider after we run truffle init from inside of the Truffle project. First thing we do is we run our truffle commit command. This command generates the directory structure that we've discussed, and then we're going to install our hardware wallet provider so that way we can deploy Truffle and sign the transactions. Okay. Just showing you my Truffle works because I'm getting back the Truffle info. I have Truffle version 5.0.2. If I decided to run I'm going to make a new directory called CryptoZombies Chapter 10, cd CryptoZombies Chapter 10. Now I can run truffle init, and then it'll set up a new Truffle project for me. It downloads everything from Truffle, it downloads it, boom. Now inside of this folder, I've got everything I need to run my Truffle project, just like what we talked about here up top in this project structure. For me, I only have this Truffle Config.js. I don't have the Truffle.js, which is one less step to be confused about. So, let's go ahead and put it to the test. First, we'll run truffle init, same thing I just did. And then once we do that, we can then install the hardware wallet with npm install truffle hd wallet provider. Boom. Got both steps. Check the answer. Good on chapter 2. Doesn't want to take me there, so we'll just keep moving manually. Chapter 3. Compiling the source code. Congratulations! Now that you put your project structure in place and set up Truffle Hardware Wallet Provider, let's compile our contracts. Why do we need to compile? Well, the Ethereum virtual machine, or EVM for short, can't directly understand Solidity source code as we write it. Thus, we need to run a compiler that will translate our smart contracts into machine-readable bytecode. The virtual machine then executes the code and completes the actions required by our smart contract. Curious about how the bytecode looks? Take a look. just a massive string of information. As you can see, a human is about as likely to read that bytecode as a real-life zombie. So using the Solidity compiler. Now that we're talking about Solidity compiler, we should mention that the devs managed to bake in some nifty features. Let's pretend we want to modify the definition of add using safe math. So we have a normal function that does not have safe math. If we're going to compile this function, the Solidity compiler will throw away a warning. Safemath.sol warning. Function state mutability can be restricted to pure. Relevant source part starts here and spans across multiple lines. Okay. What the compiler is trying to say is that our function does not read or write to or from the blockchain, and that we should use the pure modifier, because we're never actually doing anything on the blockchain. Why is this important? Well, making a function pure or view saves us gas, since those functions are not going to modify the state of the blockchain. There's no need for miners to execute them. To put it in a few words, pure and view functions can be called for free. That's awesome. Now going back to CryptoZombies the game, remember we embedded our logic in a smart contract called zombieownership.sol. Not a great name for a game. Fortunately, this is not a problem. We can use inheritance to create a smart contract with the same actions and features with whatever name we choose. Let's create a new smart contract called CryptoZombies that inherits from zombieownership.sol. Pragma Solidity. Then we've got our import of the zombie ownership smart contract, and then we say CryptoZombies is zombie ownership. Now we copied all our smart contracts into the contracts folder. Now the project structure should look something like this. Everything is set up properly. Let's compile our project. Execute Truffle Compile. This command should create the build artifacts and place them inside of the build contracts directory. Note, the build contracts are comprised of the bytecode versions of smart contracts, ABIs, and some internal data Truffle is using to correctly deploy the code. Avoid editing these files, or Truffle might stop working correctly. All we need to do for this step is Truffle Compile. It's just compiled all of our smart contracts, all of our Solidity files, and moved them to the build contracts directory. Now, okay, we're using it in a nice sandbox environment. How does it look here? Let's go Truffle Compile. I just said the wrong thing. We want Truffle Compile. It reads all of our contracts from our contracts folder. It then writes it all to our build folder, and we can see now up here we don't have a build folder, but after we ran Truffle Compile, we run ls, and then we can see, boom, we've got a build folder. And if we look inside of build, we can see that we have our contracts folder just like we do in the CryptoZombies screen, and inside of here we have a JSON folder file. And if we cat that migrations file, we can see that it's a bunch of JSON looking stuff, which includes the ABI, and like we say over here, it includes the ABI, the bytecode, and some internal data that Truffle uses to deploy the smart contract. We check, we're all good. Moving on to Chapter 4. Chapter 4, Migrations. Normally at this point, before deploying to Ethereum, you would want to test your smart contract locally. You can do this using a tool called Ganache, which sets up a local Ethereum network. Just going back, we do have Ganache installed from some of our other tutorials. If you don't have Ganache set up yet, just check out some of our other tutorials, and then you can see exactly how Ganache works. Long story short about Ganache, it's local blockchain that spins up 10 Ethereum wallets for you to use with 100 ETH, which is lots of wiggle room to be able to play around and test your applications locally before having to deploy them immutably on the blockchain and spend gas and have your users spend gas. However, while testing is very important, it requires an entire lesson to cover, so we're just going to stick to deployment in this lesson. If you're so inclined to learn about testing, recommend our very own Testing Smart Contracts with Truffle lesson. You can check that out in the previous video we just recorded. To deploy to Ethereum, we will have to create something called a migration. Migrations are JavaScript files that help Truffle to deploy code to Ethereum. Note that Truffle and Nick created a special contract called migrations.sol that keeps track of the changes you're making to your code. The way it works is that the history of changes is saved on-chain. Thus, there's no way you will ever deploy the same code twice. Creating a new migration. We'll start from the file Truffle and Knit already created for us, which is the initial migration.js. Let's take a look at what's inside. We've got migrations importing our migration Solidity file, and then we have an export, and all that it does is it deploys our migration smart contract. It's pretty straightforward, isn't it? First, the script tells Truffle that we want to interact with the migrations contract. Next, it exports a function that accepts an object called deployer as a parameter. This object acts as an interface between you, the developer, and Truffle's deployment engine. Even though the deployer provides us a multitude of useful functions, we won't be using them in the scope of this lesson. Once you finish, feel free to check out Truffle's documentation if you're inclined to learn more about Truffle's abilities. To get everything ready for deployment, we've gone ahead and created a new file, contracts to CryptoZombies.js, and copied and pasted the content from the initial migrations.js. Put it to test. Modify our new migrations file to this. We're going to be importing the CryptoZombies contract, and then our deployer, instead of deploying migrations, is going to deploy CryptoZombies. So, the only thing we need to change is change this to be CryptoZombies. And then we want to change that as the name of our variable, as well as the variable being deployed. When we check, we get it right. Now, I think the next lesson we're going to be going over actual deployment. But if we wanted to deploy, I think it's called Truffle Migrate would be the command. I haven't updated my Truffle Config.js to be in contact with my local Ganache blockchain, so it says we're not connected to an Ethereum client. You would modify this inside of your Truffle Config.js file. You would update this information to have your local ports that are all configured with Ganache. All of that info, if you have Ganache, I've already closed it, but I'm sure we'll talk about it in the next chapter. Chapter 5. Configuration files. Awesome. You've successfully compiled the source code and created a migration file. There's still one more thing to do before we can deploy. We'll have to edit the configuration file to tell Truffle the networks we want to deploy to. Wait a minute, I thought there was only one Ethereum network. What are we missing? There are several public Ethereum test networks that you can deploy your contracts to for free before you deploy them to the mainnet. Remember, once you deploy a contract to the mainnet, it can't be altered. These test networks use a different consensus algorithm to the mainnet, usually proof of algorithm, and Ether is free to encourage thorough testing. In this lesson, we'll be using Wrinkby, a public test network created by the Ethereum Foundation. Let's take a look at the default Truffle configuration file. For us, it's Truffle Config, but you might also have a Truffle.js file. You must wrap hardware wallet providers in a function when declaring them. Failure to do so will cause commands to hang. So you set up your provider as a function with the hardware wallet, a mnemonic, and then we put in the Infura address with your Infura key that we're going to be using as our provider to deploy. We've got a network ID, the gas fee, and then the gas price. It's just an empty shell. Thus, we'll be required to update this file to allow us to deploy contracts to Wrinkby and the Ethereum mainnet. Truffle's hardware wallet provider. Remember the second chapter? We asked you to install an additional package called Truffle Hardware Wallet Provider that helps Truffle sign contracts. Now we want to edit our configuration file to use Hardware Wallet Provider. To get this to work, we'll add a line at the top of the file, Hardware Wallet Provider equals required Truffle Hardware Wallet Provider. Next, we'll create a new variable to store our mnemonic. Mnemonic is onions, carrots, beans. Note, we don't recommend storing secrets like a mnemonic or a private key in a config file, but why? Config files are often pushed to GitHub, where anyone can see, leaving you open to an attack. To avoid revealing your mnemonic or your private key, you should read it from a file and add that to gitignore. We'll show you how to do this later. To keep things simple, we've copied the mnemonic and stored it in a variable. Next, set up Truffle for Wrinkby and Ethereum mainnet. To make sure Truffle knows the networks we want to deploy to, we'll have to create two separate objects, one for Wrinkby and the other one for the Ethereum mainnet. Then we'll have networks. Inside of that is an object. We've got a mainnet, and then we've got Wrinkby. We've got a provider for our hardware wallet with the Ethereum for the mainnet. And then we've got a network ID, and then for the Wrinkby network, we've got, again, the same hardware wallet with our same mnemonic. The only difference is the URL address. Note the provider value is wrapped in a function which ensures that it won't get initialized until it's needed. Wrapping it up. Now let's put these pieces of code together and have a look at how our config file should look. We should have a hardware wallet provider that's just importing the node package. Then we have a mnemonic, which is whatever your mnemonic is. We've got module exports to make this configuration available to Truffle itself. Then we've got two networks, a mainnet with a provider for a hardware wallet provider, and then Wrinkby, the testnet, with a provider of hardware wallet provider, and they each have a network ID. Put it to the test. We've gone ahead and updated most of the configuration file for you. Let's fill in the missing pieces. At the top of the file, add the line of code that initializes Truffle hardware wallet provider. Fill in the network ID for the Wrinkby network. If you can't remember the values of this parameter, check the code snippet from above. Okay, so we're gonna call this const. Well, how do they have us do it? Const, good. Const HD wallet provider equals require, and then we just put Truffle HD wallet provider. End it with a semicolon. We've got a mnemonic. We added the initializer, and then we want to fill in the network ID for the Wrinkby network, which I guess is 4. Let's check. Okay, maybe we needed double quotes. We needed double quotes for this to pass. Maybe. That wasn't it. What am I doing? Let's try copying this. Okay, we're not liking... Oh, maybe we don't need the quotes because it is a integer. No. What am I doing? Oh, there we go. Okay, got it. Okay, so taking one quick step after this, let's see how we would do this locally. I don't know that we need to use the hardware wallet right now, but I mean, might as well, right? So let's go to our Truffle Config file. Then inside of our Truffle Config, we'll take care of it just like we did over here in Brave. We'll refresh this page. Hopefully it keeps our work here the same. It does not. This is inside of our deployment package, so we'll take our hardware wallet. We'll go back to code. We're going to actually just delete everything, and then we'll copy it all from what we just did over here. And we want network IDs to be 4. And then we need tokens for the Infura.io. You know what? Let's set it up for Ganache. So let's look up Truffle Ganache config. And hopefully they've got an example. There it is. So we'll keep it right there. Let's see if it works right now with Truffle Migrate. Let's see if it's hooking up to the right place. Okay, we're not properly configured. Okay, so how do we find that? We'll go up to settings. So let's try to find what... Oh, I don't have Ganache running. Maybe that is why. So we're going to open up Ganache, our local blockchain. Once we've opened Ganache, now first let's just try deploying it with the default settings we got from Truffle. Let's try it. Okay, does not match that returned by the network. Ensure that both the network and provider are properly configured. So it looks like network ID is actually going to be 5777. Let's try it again. Did I save it? I did save it. Boom! We just deployed our contract to the Ethereum blockchain. Well, our local Ethereum blockchain. And we can see that our balance, we just had a transaction, but it didn't even cost enough to lower our balance. It was 0.004 ETH. We just deployed it again. We've now decreased our ETH balance. So that was a little bit of a tangent, but this is how you would deploy it on your local blockchain if you want to do some local testing. Let's go back to the tutorial. Back in CryptoZombies, we're going to move on to Chapter 6. So we already finished Chapter 5. We've just passed halfway. Oh, I thought I finished this. We'll go const hd wallet equals require Truffle hardware wallet provider, and then we want our network ID to be 4. Got it. Moving on to Lesson 6. Chapter 6, deploying our smart contract. Great, that was the difficult part. Actually deploying to Wrinkby is going to be pretty straightforward. To do this, Truffle relies on something called migration. Migrations. It sounds like a migration involves a lot of stuff moving around, but in practice a migration is nothing more than a JavaScript file that tells Truffle how to modify the state of our smart contracts. Obviously, the first migration will just deploy the smart contract. Some other migrations deploy a new version of the code to add features or fix bugs. In a nutshell, migrations provide a convenient way to keep track of the changes you make to your code. If you want to deploy more than one contract, a separate migration file must be created for each contract. Migrations are always executed in order, 1, 2, 3, etc. In this lesson, we're going to deploy to Wrinkby. Deployment to the mainnet would require real money to pay for gas, and once deployed, we won't be able to modify the code. Hence, it's best to deploy to Wrinkby first and thoroughly test the code. Get some Ether. Before doing the deployment, make sure there's enough Ether in your account. The easiest way to get Ether for testing purposes is through a service known as a faucet. We recommend Authenticated Faucet, which runs on Wrinkby. Following the instructions and within a few minutes, your address will be credited for some Ether. Put it to the test. Now that everything is set up, it's time to deploy to Wrinkby. To do so, run Truffle Migrate network Wrinkby in the terminal to the right. Note how migrations are being executed in order. Note, Truffle Deploy is just an alias for Truffle Migrate. However, since our command line interpreter is pretty basic, it won't consider the answer correct unless you're using Migrate. Deployment to the mainnet is not complicated at all. Once the smart contract is tested, you'll only have to run Truffle Migrate -- network mainnet. Don't forget that you'll have to pay for gas. We trust you'll be able to do it. If everything goes well, you're going to see a response that's similar to the one on the right. Okay, so let's just run Truffle Migrate -- network Wrinkby. I spelled Wrinkby wrong. So we'll go Truffle Migrate -- network Rinkeby. There we go. Deployed the first one, deployed the second one, then we were done. Now, so when we check our answer, we should be good. We're all good. I want to take a second and go into fueling our wallet with something from the faucet. So we'll move on to Chapter 7. And before we actually start Chapter 7, we've got this Authenticated Faucet. And if you want, you can just look up Wrinkby Faucet. And then you'll see the Authenticated Faucet. And if you want to look up Ethereum test faucet, that should also give you Ropstein, Wrinkby, whichever testnet you want. So what I would do here is I would say a social networking URL containing your Ethereum address. So I'm going to go ahead over to MetaMask. I need my password. MetaMask, we'll search for MetaMask, copy the password, go back to MetaMask, MetaMask is a plugin for any browser. It's just a browser extension that is pretty much your gateway to using decentralized apps. Now we're on Wrinkby network, so I want to change this to Wrinkby test network. And now I've got a main Ethereum account that I can just copy the address. It's a public address. I can paste it in. And I can say give me ether. And I'll say 18 ethers. URL doesn't link to supported services. I thought I was on Wrinkby. Wrinkby, I'm not connected, that's okay. In my main Ethereum account, I'm on copy it. Oh, did it get it? Let's check out MetaMask. I might have just gotten some ether. We'll be patient while the block processes. It says I was funded. Did I actually get my ether? Where is my ether? Let's try refreshing. Refreshing might not work. Let's go down to 3 ethers. URL doesn't link to supported services. Not sure what is going on there, but I'm not seeing my ether. You can track the current pending requests below the input field to see how much you have waiting until your turn comes. To request, okay, so I guess we have to prevent malicious actors from exhausting all available funds or accumulating enough ether to mount long-run spam attacks. Requests are tied to third-party social network. Anyone having a Twitter or Facebook account may request funds within the permitted limits. To request via Twitter, we'll make a tweet. Okay, I guess we have to make a tweet. So we'll open up this link to Twitter. Copy paste the tweet URL. Okay, so we'll just tweet. Got it. We're going to tweet that. And now I think I just want to copy the link to the tweet. Oh, I need my Ethereum address pasted into the contents. I'm going to delete that tweet. Delete it. I did the wrong thing. Okay, so I need to open up this Twitter again. And now I'm going to copy the MetaMask public key. If MetaMask decides to open, I'll copy my address. Paste it. Tweet it. Now I'm going to copy the link to the tweet, paste that in there. Give me 18 ethers, please. There we go. There we go. Fully funding requested accepted. For Sweetman Tech, it says I was funded. Did I get my funding? Did I get my funding? Looks like I now have 18 ether inside of my main Ethereum account on the Wrinkby test network. So that is how you fuel your Ethereum wallet. Now if I want to go onto a website that needs to be connected with MetaMask, I can connect it using this test account and I can test my decentralized applications. That's it for Chapter 6. Now moving on to Chapter 7. Chapter 7. Use Truffle with Loom. It might not seem much, but you just deployed the CryptoZombies smart contract. Even if Truffle helped a lot, there's no small feat. So pat yourself on the back. The Loom to base chain. If you want to build DApps on Ethereum, there's one thing you should be aware of. On the mainnet, users are required to pay gas fees for every transaction. But this isn't ideal for a user-facing DApp. For a game, it can easily ruin the user experience. Conversely, on Loom, Your users can have much speedier and gas-free transactions, making it much better for games and other non-financial applications. This means that your Loom zombies will be fast zombies. That's not all. Deploying to Loom is no different from deploying to Wrinkby or to the Ethereum mainnet. If you know how to do one, you'll also know how to do the other. In the next chapters, we'll be walking you through deploying to Loom. Loom Truffle Provider. We at Loom are using Truffle to build, test, and deploy our smart contracts. To make our life easier, we just developed something called a provider that lets Truffle deploy to Loom, just like it deploys to Wrinkby or Ethereum mainnet. Without delving too much into details, the provider works like a bridge that makes Web3 calls compatible with Loom. The beauty of it is that, to use it, you don't have to understand how it works under the hood. We've made Loom Truffle Provider available as an NPM package. Let's install it. So we are just going to npm install Loom Truffle Provider. And we got it. So we just finished chapter 7. Now I want to, before we move on, look at these gas costs that they're talking about by building on Ethereum main chain. So today I was thinking of publishing one of my works of art on OpenSea, because OpenSea is a great platform and it seems to be where a lot of artists are publishing their art, and they're able to earn their money on it. Now when I go to OpenSea, there's no explore page for me, or there's no sign-in page for me. Instead, your identity is connected to your wallet. Now right now my wallet's on the Wrinkby testnet, so I need to switch it into the Ethereum mainnet. As soon as I do, it updates my total, and now I can see everything I've created on OpenSea. So today I wanted to sell this piece. This spiral I made is generative art that I built with some computer program, so I was able to create this art pretty quickly. Now I want to sell it, so in order to sell it, I have to publish it onto the Ethereum blockchain. Now let's just throw in some values here and let's post the listing. So I now need to approve the transaction using MetaMask, which is going to open up my MetaMask and then prompt me to post the transaction onto the Ethereum mainnet. We can see that the gas fee for me to publish the transaction is $15. So, like, for example, on eBay, if I wanted to list a new product, it wouldn't cost me anywhere near $15. Or if I wanted to post a new song onto Audius, it wouldn't cost me $15. But the gas fees right now are really high, and it's $15. I was looking earlier today and I wanted to post around noon in Indo-China time here in Thailand, and the gas prices were still like $11. So if you're selling a $10 piece of art and it's expected that you're doing at least $15 to publish it, you're going to be spending more just to publish the art on the platform than you'll actually make when you sell it. So I'm going to reject this. I'm going to go back, and that is just a little example of what CryptoZombies is talking about when it says that gas fees are associated with deploying onto the Ethereum mainnet, which is, there's benefits of then using an alternative like Loom, or deploying on a testnet, or deploying on something like Polygon, or deploying on something such as Arbitrum. There's all of these nice Ethereum scaling solutions that will eventually write back and use the settlement layer of Ethereum, but they'll do stuff like wrapping everything together. They will aggregate a bunch of transactions and publish that to Ethereum, which saves each of us developers time and money, but also gives us that nice settlement layer that we like of the security of Ethereum. That's my rant. Let's move on to the next lesson. Next lesson, we're on chapter 8, deploy to Loom testnet. In this chapter, we're going to deploy our smart contract to the Loom testnet, but before doing the deployment, some prep work is needed. First, we should create our own Loom private key. The easiest way to do it is by downloading and installing Loom according to this tutorial. Next, creating a private key is as simple as this. We access our Loom folder, we generate a public key and a private key. And then it outputs our Loom address, our base64 address, our private key. Never reveal your private keys. We're only doing this for simplicity's sake. Updating Truffle Js. The first thing we're doing is initializing the Loom Truffle Provider. The syntax is very similar to the one we've already used for Hardware Wallet Provider. Instead of importing the Truffle Hardware Wallet Provider, we will import the Loom Truffle Provider NPM package. Just as we did in Chapter 5, we'll have to let Truffle know how to deploy on the Loom testnet. To do so, let's add a new object to Truffle Js. We've now got a provider function, which is a little bit more complex than we had for the Truffle hardware wallet. Private key, which we just generated using the Truffle CLI. Chain ID, write URL, read URL, and then the Loom Truffle provider. That was a mouthful. Put it to the test. Add the line of code that initializes Loom Truffle provider. Place the configuration for Loom testnet near the bottom of the file. First thing we want to do, import the Loom Truffle provider. We're going to, I guess not change anything, we're just going to import a new variable called Loom Truffle provider. We're going to set it equal to requiring the node package, Loom Truffle provider. Put our beloved semicolon. Then we add the configuration for Loom testnet down near the bottom. We'll just copy the entire Loom testnet because I probably won't be building with Loom. Not that they're not awesome. Love you, Loom. Thank you for the CryptoZombies tutorial, but I haven't heard anybody using Loom. I've heard of people using Polygon. Polygon seems... I like having the base settlement layer being Ethereum. There's a lot of security you get with using Ethereum. And although there are benefits to using Loom, like building a game where customers don't need to worry about transaction costs, I can get that while still getting the secure benefit of Ethereum on layer 2 scaling solutions like Polygon and Arbitrum and Optimism, all those solutions. Looks like I did something wrong in the import. I used double quotes instead of single quotes, which is weird because the first one required me to use double quotes, but this one looks like is requiring me to use single quotes. But it can be like that sometimes in tutorials. Moving on to Chapter 9, 9 out of 11. Chapter 9 continued, deploy to Loom continued. Now we've got everything in place. We've now switched over to our command line view. Now we use Truffle Migrate network Loom testnet and check the output. Again, this is just like what we did on our actual command line where we ran Truffle deploy. And so we've just deployed. Here's the address of our smart contract we just deployed. If we deploy it again, this one ends with B07D. If we deploy it again, we'll have a new contract address. This new contract ends with CO16. We can use the exact same deployment method that they use with Truffle Migrate. What's the name of the network? Development. So we can just run Truffle Migrate. And also, if we want to specify the network, we can run Truffle Migrate --network and then paste our network name that we defined in our Truffle Config file. It's just a little added specificity. Either way, we've just deployed multiple times to our blockchain. On to the next lesson. On to Chapter 10. Chapter 10, deploy to the base chain. Congrats, you've successfully deployed the Loom testnet. But can you guess what's coming next? Yep, you're right. This chapter will walk you through the process of deploying the base chain. That's Loom's mainnet. Here's a brief rundown of what we'll do in the chapter. We will create a new private key. We'll create a new private key, which is pretty straightforward, but since we're talking about deploying to the mainnet, it's time to get more serious about security. Thus, we'll talk about how to securely pass the Truffle or the private key to Truffle. We'll tell Truffle how to deploy to base chain by adding a new object to the truffle.js config file. We'll whitelist our deployment keys so we can deploy to base chain. And lastly, we wrap everything up by actually deploying the smart contract. Creating a new private key. We already know how to create a private key, however, we must change the name of the file in which we're going to save it. Securely pass the private key to Truffle. The next thing we want to do is prevent the private key from being pushed to GitHub. To do so, let's create a new file called gitignore. Now let's tell GitHub that we want to ignore the file in which we saved the private key by entering the following command. This is the name of our file. We'll then add that file to our gitignore. Now that we've made sure our secrets aren't going to be pushed to GitHub, we must edit truffle.js config file and make it so that Truffle reads the private key from this file. Let's start by importing a couple things. Read file from our file source node module. We'll import path as well as the path and join helpers, imports. Next, we want to define a function that reads the private key from a file and initializes a new Loom Truffle provider. Function get Loom provider with private key is a new function. We get the private key path, the chain ID, the write URL, the read URL. We then read that from our local path, and then we initialize a new Loom Truffle provider with the information. Pretty straightforward, right? Next up, tell Truffle how to deploy to base chain. Now we must let Truffle know how to deploy to base chain. To do so, let's add a new object to truffle.js. We've got a base chain with a provider function. It's got the same provider information, and then we've got a network ID. The only difference is we're using this get Loom provider with private key method, which we talked about in the previous code example. At this point, your truffle.js file should look something like the following. We import a bunch of functions. We import our new function. We create our new function called get Loom provider with private key. And then down at the bottom, we've got our base chain networks with all of this provider info. Whitelist your deployment keys. Before deploying to base chain, you need to whitelist your keys by following the instruction from deploy to mainnet guide. Don't worry about it right now, but keep in mind that you have to do this after finishing your tutorial. We've gone ahead and performed all the steps, and now we're ready to deploy to base chain. Run Truffle Migrate --network base chain, and that is what we got to do to deploy. We're going to run Truffle Migrate --network base chain. That will deploy it. We can see the contract address of each of the contracts we deployed, and we got successes. Total cost 0 ETH. Check the answer. We're all good. Moving on to the final chapter of this lesson, 11. That is it. Well done. You mastered the art of deploying smart contracts using Truffle. Remember, building on top of Loom builds you faster, gas-free transactions and make it the perfect choice for creating blockchain games and user-facing DApps. At the same time, your users will enjoy the guaranteed security that Ethereum provides. Wait, Loom provides the security of Ethereum? Another thing to remember is how similar deploying to Loom is to deploying to the Ethereum mainnet. You now know how to do both, just be careful how you choose which one you want on your next project. Anyway, this is just an example. We made several decisions that simplified things a bit to make the lesson easier to understand. To further your knowledge, head over to the developer documentation page. Happy coding. Thanks everyone for staying tuned. I'm going to do a little bit of extra research, but if you're going to go ahead and clock out, that was the end of the lesson. Thank you for joining me today. If you've stayed on, we're now looking at the Loom network. To try to understand how we still get the same level of security that we get on Ethereum on Loom. It's a multi-chain interoperability platform that's connected to many other blockchains such as Ethereum, Binance Chain, and Tron. Deploy your dApp once to the base chain and reach the largest user base possible so you can simply focus on your dApp development and business growth. We have no gas fees for users, 1 to 3 second confirmation times, and automatically get connected to every major blockchain using any kind of wallet. Okay, when does it end up getting written back to Ethereum? If you've ever deployed to Ethereum, very similar. We're interoperable, we're actively supporting new networks. Don't get locked in. Loom on Ethereum. It's a side chain built to power a wide range of decentralized applications. Loom Network is a blockchain scaling project focused on education and social application. The network itself runs on Plasma, a scaling solution to Ethereum, which allows faster transactions through the network.